All right, seventh graders, here we go. We're learning about equations. We're doing algebra. We are off and running. I want to teach you a few things today that we went over in class a little bit, and I want to cover in a little bit more in depth and maybe give you a little bit more rationale and also give you an opportunity to have something that you can refer back to, rewind, pause, and consider. These are the basics of algebra. These are the basics of solving equations that we're going to build the foundation that we will never forget. We will come back to it. It will serve you well in later in algebra, geometry, all the way up to calculus, and just knowing how to solve these 1- and 2-step equations and how to know what to do first is so critical. So let's see if we can build an intuition around that by working a number of problems. Today in this lesson, we're going to stick to 1-step equations. Follow on lesson that I'll post today or tomorrow will also include 2-step equations and multi-step equations. I will explain what all that means as we venture forth. So let's go to let's see. Let's go to this screen here. No, wait a minute. I got to figure out what screen we're going to go to solve this stuff. We're going to go to this screen. It's going to get a little weird here for a second. And then we're going to go to this screen here. And I think we're on the right screen. Yes. Okay, good. All right, we are going to start now, and we're going to talk about, let's just look at an equation. We're going to start with an equation like this. Now, again, why is this an equation? An equation is two expressions. In this case, we have x plus 2. This is expression 1. And this is expression 2. And they are separated by an equal sign. Okay, two expressions separated by an equal sign is what an equation is. Equation is two expressions separated by an equal sign. All right, so given that, we're going to talk about how we solve an equation. And so let's look at this. So solving an equation means finding the value of the variable that makes the equation true. Makes the equation true. The equation true. Here, let's just rewrite that. The equation true. And so in this case, you can figure out, and you can probably do by inspection. Upon inspection, you can say that the answer must be, let's use this, x equals 6. Because you know that 6 plus 2 is equal to 8. You can kind of look at it, and you can actually test that out. You can always check your answer by substituting your solution into the original equation. So the way that we check our answers, we go back to our original equation and we say, well, x plus 2 equals 8. Our solution of x equals 6, well, we're going to take that x, and we're going to replace it with our solution and see if it's true. So if I replace x with 6, and I say 6 plus 2 is equal to 8, well, 6 plus 2 is equal to 8, and 8 does indeed equal 8. So we have checked our solution, we've checked our answer, and we have completed this problem. Now, I'm going to come back to this concept of checking our answer and looking at our, by evaluating both expressions and substituting in our answer, but we'll come back to that in a little bit. We're going to now talk about how did we solve this equation? How did we find out that x is equal to 6? We kind of looked at it and knew, but I want to go through some formal methods for solving it because we're going to need to know how to do them when we start to solve our two-step and multi-step problems in our future our future problem solving. So let's look at a different problem, and let's look at one that might be a little bit trickier. And let's look at x minus 32 is equal to 49. Okay, the first thing I want to do is I want to talk about what this means in English. So in English, we describe this as saying, some number, we'll write this in English. Say some number, and that number is x, minus 32 is 49. That's our English version. So some number that we take, we subtract 32 from it, and we get 49. Okay, so that's something that we'll need to use this in some of our homeworks, and I want to have some notion of taking algebra and converting it into English. We could also make a more sophisticated word problem out of this, and we could say something like, well, I have a bank account with some money in it, and I take out $32 and have $49 left. How much did I start with? So this is another way to put some English on top of this sentence. It's just a sample verbal model, if you will, or a sample word problem. At any rate, let's talk about two key concepts when we are solving, when we solve this. Solving dash key concepts. Concept number one is in an equation, whatever I do to one side, I must do to other side. Just hold on to that thought for a second. So if I have a balance, let's just go into that. So if I have a balance, if I think of this as a balance, and I have on it one side I have 49, and on the other side I have x minus 32. If I add 10 to this side, if I add 10 pounds, $10, whatever, to this side, to keep the balance even, I have to add 10 to the other side, right? So that's the idea of, that's going to be the idea of balancing, and whatever I do to one side, if I must do to the other. If I subtract 5 from one side, here, let's do to this. So if I go minus 5 to this side, to keep this balance, I have to subtract 5 to this side. Similarly, I could multiply both sides by 10, or I could divide both sides, okay? So let's go back and let's look at point number 2. And this is the point of undoing operations. Undoing. And this is not a mathematical term, but it's kind of like the opposite opposite function. So let's think about this. If I have a number and I add 10 to it, to get back to x, I have to subtract 10. Right? So think of a number, any number, and add 10 to it. If I subtract 10, I am back at that number. So if x is 6, then 6 plus 10, to get back to 6, I have to subtract 10, and then I get my 6. And that's true for any number. So if I take x plus 10, and then I subtract 10, I get back to my x. Okay? So the way that we undo addition is undone with subtraction. And subtraction is undone with addition. Similarly, multiplication is undone with division. And division is undone with multiplication. So let's look at the multiplication and division examples. So if I say 5 times x, the way I undo it is I divide by 5. So let's think about that. If I have a number 10 and I multiply it by 5, that's 50. But then if I divide by 5, I get back to 10. Think of any number in the world and multiply it by 5. And then divide it by 5, and you get back to that number. So 2 times 5 is 10, divided by 5 is back to 2. So any number multiplied by 5 and then divided by that same number, 5 is equal to 2. Similarly, if I divide a number by 5, you can run this experiment yourself. If you divide a number by 5, then you have to multiply by 5 to get back to that number. So I'm going to erase this side of the board because I want to keep these key concepts in your mind and on the board as we go through some of these problems. There we go. Get rid of this thing. So we're going to keep into mind, whatever I do to one side, I must do to the other, and keep in mind the undoing operations of addition undoes subtraction and multiplication undoes division. Okay, so let's try this. X minus 14 equals 22. So we want to figure out what x is. So if I want to take this, and let me do it like this. Let me say it's equal to 22. Now, you'll see why in a second. So remember, if I want to get back to x here, and I start with x minus 14, to undo my subtraction of 14 and figure out what x must be, I have to add 14. Because adding 14 undoes subtracting 14. So that's point number 2. Now, point number 1 says, whatever I do to one side, I must do to the other. So if I added 14 to the left side, I have to add 14 to the right side. So let's look. Let me write my original problem down here again. It's x minus 14 equals 22. Let's get rid of that. Okay. Okay, so now, again, x minus 14 plus 14 is just equal to that original number. Right? So x minus 14 plus 14 gives me x. Right? Any number minus 14 plus 14 equals itself. And on the right side, I get 22 plus 14. So that's 36. So I've solved my equation. X equals 36. Now, that's my solution step. Now, to go back and check my equation, I have to go back to my original equation. And to check my answer, this is my check. I have to put my 36 in for X. So I'll say 36 minus 14. Does that equal 22? Well, let's see. 36 minus 14, 2, just 22 equal 22. Yes, it does. So that's how we solve a subtraction, a one-step algebraic subtraction equation. Let's try another. Feel free to pause and rewind this video, make notes, ask questions, because I'm happy to do more of this as more videos, or to come back in class and do more of this. So let's try this one. Let's see, X plus 10 equals, well, let's do it like this, equals 6. Wow, this one's a little tricky. I'm not so sure about this. But let's see what I have to do to solve this one. So we're going to copy our problem. X plus 10 equals 6. So I want you to think about what undoes addition and what undoes adding 10. What can get me back to X? And I will pause the video and then come back. So pause. Okay, now I assume you paused. And if you add 10, you're right. For those of you who said undoing addition is undone with subtraction. So that's point number 2, undoing. Positive 10 means subtracting 10. So if I subtract 10 now, the second point is if I subtract 10 from the left side, I have to subtract 10 from the right side. And so X plus 10 minus 10 is indeed our original X. Now 6 minus 10, we have to go back to unit 2 and remember how to do this. 6 minus 10, one way to do it is simply to do your boxes and then do your evaluation. So I'm going to say here's 6 and a minus 10. A 6 and a minus 10 is got to be, a negative 10 is bigger than a 6, so my answer is going to be negative. And 10 minus 6, that's going to be negative 4. For those of you who do 6 minus 10 differently and come up with negative 4, that's great. This is just one of about 5 different ways we learned how to do it. So now that we have X equals minus 4, what do we do next? Okay, for those of you who said check your answer, you are right. So we'll take our negative 4 and plug it back into our original equation. X is negative 4, so we're going to take our negative 4 and put it in for X. Negative 4 plus 10 equals 6. Well, negative 4 and 10 is negative 4 positive 10. That's a positive 6. That equals 6. That works. Check. Okay, good. Let's do one final problem. And then we'll do a video. Another video. So let's do this one. 5x equals 30. 5x equals 30. Okay, so I have to ask the first question. What undoes multiplication? Division undoes multiplication. So we need to divide. Let's divide by 5. Well, 30 divided by 5 is 6. And 5x divided by 5 is just x. right? 5 times x divided by 5 must be x, because division undoes multiplication. So now we get x is equal to 6. We box our answer, and are we done? No, we must check our answer. To check our answer, we go back to our original equation, and we plug a 6 in for x. So 5 times 6 equals 30. Does 30 equal 30? Yes, it does, and we have our answer. So what I'd like you to do now is here are some optional, or well, let me just write down some problems here. Some one-step problems. Let's make sure you can do them. X plus 9 equals 42. To x minus 3 equals 8. And then 3 will be x divided by 3 equals 14. Okay, pause the video, try these on your own, and then we're going to come back and we're going to solve these. Okay, let's solve number 1. So what undoes addition is subtraction. So we're going to subtract 9. Now, instead of writing it right behind it, we're going to write it underneath it. Look at that. We're going to subtract 9 from both sides. Now, we could have written it to the right, but we're going to write it underneath. And this is kind of nice because you kind of see how the positive 9 and the negative 9 kind of cancel out. And you're just left with x. And now we've lined up our numbers to make it easier to subtract. X is 33. And now we're going to check our answer. We're going to go back to our original problem and say, well, x is 33, so we'll write check up here. And we'll write 33 plus 9 equals 42. Well, 33 plus 9 is 42 equals 42. Check. So there's our first answer. All right, moving on to our second one. What operation undoes subtracting 3? Well, adding 3. So x is equal to 11. And we'll come in here and we'll do our check step. We'll put our 11 in for x. 11 minus 3 equals 8. Does it? Well, does 11 minus 3 is 8. Check. All right, fine. Last but not, well, it is last. So it is last. So x divided by 3, what undoes division? Multiplication. So we're going to multiply by 3. We're going to multiply both of these by 3. And we get x on the left. X divided by 3 times 3 is just x. And 14 times 3 is 42. Let's check our answer. Does 42 divided by 3 equal 14? Well, let's take 42 divided by 3. 1, 3, 1, 12, 14. Yes, so 14 does equal 14. Check. Okay, so there we have it. We are done with problem set, or kind of solving equations part 1. I'm going to move on to solving equations part 2, where we're going to do double step, two-step, and multi-step equations, and I will post that following this one. It dovetails with what we've done so far, but it takes you to that next level and allows you to solve any equation that has more than one step to it. Okay, hopefully this was helpful, and if it was helpful, I want you to cheer. Another perfect video. Thank you so much. We'll see you soon.